Hi, dear students. We are studying basic properties of vectors. During this course, lately we have studied addition of two vectors. Also, we have studied its properties. Today, we shall solve problems based on it. The very first problem says that I have two vectors, say vector A and vector B. And if I write like this, these are magnitudes. So magnitudes of vector A and B. I am going to add these two vectors and I am getting the resultant vector and the magnitude of the resultant vector. So the question is, the magnitude of the resultant vector is twice the magnitude of A, which in turn again it's equal to twice of the magnitude of B. I repeat, I have two vectors A and B. The two vectors are added to produce a resultant vector R. Now I talk in terms of the magnitudes of vector A and B. I find that the magnitude of the resultant vector is twice of the magnitude of A, or say twice of the magnitude of B. Now question is, find the angle between the two vectors. So find angle between two vectors, say theta between two vectors. This is what the question is. So to solve, what I am going to do is, I am going to assume that the magnitude of A, vector A, definitely is going to be equal to magnitude of B. I say this is equal to X. This is equal to X. So if magnitude of A is equal to, B is equal to X, in that case the resultant will have a magnitude of twice of the magnitude of this. Therefore, I see that the magnitude of the resultant vector is going to be twice of X. We have studied the analytical formula for calculating the magnitude of the resultant vector. The general formula we got like this: R was equal to root of A square plus B square plus twice of AB cos theta. Now I am going to substitute these magnitudes. So for this I am going to have twice of X, which is equal to under root of A square. For me it will be X square plus twice A and B will have X into X of cos theta. Else I have 2x square when I find the sum plus 2x square cos theta, which is equal to 2x. I find that 2x square common. So therefore, when I take out, I am going to take out x, and I have here 2 plus 2 cos theta, and this gone. X and x gone. So I am left with 2 is equal to under root of 2 plus 2 cos theta. In that case, I am going to square both sides. So squaring both sides, I am going to have twice squared will be 4, and when I square right hand side, the square root goes off and I am left with 2 plus 2 cos theta. Otherwise 2 is equal to twice of cos theta. Otherwise cos theta is equal to 2 by 2, which gets me 1. So for what value of cos theta is equal to 1, we know theta is definitely 0. What we mean is that from here we get an idea that the magnitude of vector A and vector B are equal. At the same time, these two vectors are parallel to one another, like this. So this is vector A, this is vector B, and thus solved. So we found the angle between the two vectors theta to be equal to 0, which indicates that the two vectors are, say, parallel vectors. Let's try to see one more problem. This problem says that we have two unit vectors, and I'm going to find the sum of the two unit vectors. So I'll get the resultant one, the resultant vector is also a vector of unit magnitude. Let me explain it on the board. I say that I have a vector, say one vector, which is a unit vector I said. That means its magnitude is 1. Another vector I have, second vector, again the magnitude of this vector is also 1. Unit vector I said. Now I am going to add these two vectors and I am going to get the resultant vector. I said the resultant vector also has got the magnitude 1. And the question is, find the angle between two vectors. Find the theta between two vectors. This is our question. Now, how to go about it? It's very simple. We have the general formula r is equal to under root of a square plus b square plus 2ab cos theta. Simply, I am going to substitute the values. Already it's given. So magnitude of r is equal to 1. Under root of a square happens to be 1. Square say, which is equal to 1. 1 square plus 2 into 1 times 1 of cos theta. And here this is 1. 1 plus 1 is 2. So 2 plus 2 cos theta. I am going to square both sides. So squaring both sides, I'll have 1 is equal to 2 plus 2 cos theta. 2 if I bring this way, so this will be minus 1, 2 cos theta. Otherwise, I'll have cos theta is equal to minus 1 by 2. Otherwise, for what value of theta? Its value is minus 1 by 2. We see that theta will be equal to 120 degree. This is an important result. Similarly, if the problem is extended like this, let us try to find. In the previous problem, I said that the magnitudes of the two vectors a and b are 1. That means a and b were unit vectors. Resultant vector was also having a magnitude of unit vector. Now let us assume the next problem. I say that two vectors I have a and b, both are of equal magnitude. This time the magnitudes are not 1. They are having equal magnitudes, and I say the resultant vector also has a magnitude equal to the magnitude of say a or b. What I say, the problem goes this way. The two vectors I have and the magnitudes of the two vectors are equal, and I am finding the sum of the two vectors. The resultant also has the magnitude equal to the magnitude of either it's say a or b. So mathematically I can say like this, and I am asked what is the angle between a and b. A and b. I'm going to go the same way. So I have r is equal to under root of a square plus b square plus 2ab cos theta. So let me assume vector a has a magnitude of x, b will also have a magnitude of x, and r will also have a magnitude of x. So let the magnitude of a, b and r is equal to x. In that case, I will have on substitution x square plus 2 times x into cos theta. Otherwise, x is equal to, I have twice of x square plus 2x square cos theta. When I take x square common and take out of the root, I am going to have x under root 2 plus 2 cos theta. This and this goes, I am left with 2 plus 2 cos theta. Hopefully you can visualize the situation. I hope the same situation I had here. I had the same situation. So I'm going to get the same result. So I'm going to have cos theta value equal to minus 1 by 2. Then theta will be equal to 120 degree. So thus if I compare this problem and this problem, one thing I understand that here two unit vectors on summing up magnitude of the resultant was equal to the magnitude of this one. Here also I see that the magnitude of A is equal to B is equal to the resultant vector. In that case, then the angle between the two vectors is theta. So irrespective of the magnitudes, if I have two vectors of equal magnitude and the resultant produces the same magnitude, then always the angle between the two vectors will be 120 degree. How? Let me show it on the diagram. So let's say this is vector A and I want 120 degree. So 120 degree, shall I rub this one to get some space? So this is vector A and vector B. To get 120 degree, this is going to be 90 degree. So somewhere here. So say this is 120 degree because we know the angle between two vectors is that angle when the two vectors have their tails coinciding at the same point. So now if I use the parallelogram law of vector addition, then see please the diagonal that joins tail and tail of the two vectors A and B and head of the two vectors, then this will be my resultant vector. Now what my problem says is the magnitude of A, the magnitude of B and the magnitude of the resultant vector are equal. In that case only it is possible if the angle between the two vectors A and B is 120 degree. So let's try to solve one more problem. What it says is I have a vector which has a magnitude of say 30 and is pointing along 37 degree at say north of east. So I say like this, this is my first vector. And the second vector is vector B, which has a magnitude of say 30. It has got its own unit, okay, and 30 unit at 37 degree, let's say 37 degree, I say south of east. One vector A which has a 30 unit at 37 degree north of east. Vector B has 30 unit at 37 degree south of east. When I wrote unit, it has got its own unit, maybe meter. So if it's meter, for both it's meter. Now I want to add these two vectors. On addition, I'm going to get the resultant one. You have to calculate the resultant or say magnitude of the resultant of the sum of the two vectors A and B. On addition, I am going to get and I want to calculate what is the magnitude of the resultant of the sum of the two vectors. This is what my question is. So how to go about it? Already we have studied how to represent north, east, west, south direction. So let's say this is north, east, west and south. Now it is said that vector A is 30 unit along 37 degree north of east. So this is east. 37 degree north of east I am going to have here. So this is for me 37 degree. And this is vector A for me. And next says this vector B is 30 unit at 37 degree south of east. So east, south this way. So I am having the second vector this way. So this is vector B for me and the angle is once again 37 degree. If I see the total angle, this is going to be 74 degree. Rather say if this is theta, then this is theta, then total angle is 2 theta, I can say. Now I want to find the sum of these two vectors. To find the sum of the two vectors, once again I am going to use the same formula. Magnitude R will be equal to A square plus B square plus 2AB cos theta. I have to find the magnitude of R, so I am keeping as such R. This is equal to under root of AB. Magnitude of A is 30, magnitude of B is 30, so I would say that this is 30 square plus 30 square plus 2 times A is 30, B is 30, and cosine of theta. Theta is the angle between the two vectors. To find the angle between the two vectors, the tails of the two vectors must coincide, which is doing so. Therefore, the angle between them is 74 degree. So as such, I write here it is 74 degree. Rather, I can also write this as 30 square, 30 square. Here too I have 30 square. I can take common out. So 30 square taking out of square root is going to give me 30. Then I will be left with 1 plus 1, which will be equal to 2 plus 2. Cos 74, I am going to write cos 2 times of 37. This way I am going to write cos 2 theta. Now, cos 2 theta can be written as cos theta plus theta. So cos A plus B, which can be written as cos A cos B minus sin A sin B. Otherwise we have cos square theta minus sin square theta. This can also be written as cos square theta minus sin square theta can be written as 1 minus cos square theta. When I open the bracket, I'll see that this is cos square theta. Otherwise, this will be twice of cos square theta minus 1. So cos 2 theta can be written as 2 cos square theta minus 1. In that case, I shall write R is equal to 30 under root of 2 plus 2 into cos 2 theta can be written as twice of cos square. Theta is 37 for me, so 37. I can write, instead of writing like this, I can write square minus 1. So twice of cos 2 theta can be written as 2 cos square theta minus 1. If that is the case, then R is equal to 30 under root 2 plus 2, or if I open bracket, this is going to be 4 times cos 37. When I write, see, two angles are very important. One 37 degree and another one is 53 degree. So thus the standard values here we have like this. So when I say 37 degree this right angle triangle makes, then hypotenuse is going to be 5 and this is going to be, base is going to be 4 and this is 3, which we need to remember. Now if this is 37 degrees, this is 90 degree, this is 37, definitely this is going to have 53 degree. So in that case, if I redraw once again like this, so if I have this angle as 53 degree, then again this is 5, this is 3 and 4. So these two triangles we must remember. So here in our case cos 37, when I say 37, so base by hypotenuse, so cos 37 for me is 4 by 5. So I write 2 into 2, 4 times cos 37 is 4 by 5 and square minus 2 into 1 is 2. Or I write R is equal to 30 under root 2 plus 4 times 16 upon 25 minus 2. Or this would be, if I solve this, I'll get 30 under root of 25. I get 25 into 2 is 50 plus 4 times 16 is 64, 25 minus into 2 is 50, and whole divided by 50. Minus 50 plus 50 gone. So I am left with under root 64 upon 50. So this will be 8. I can take out and denominator it's 25. So 25 I can take out 5. So therefore this has become simple. So R is equal to 30 into 8 upon 5. If I work out this, it is going to be 6. So the magnitude is going to be 48 units. So this is the answer for this problem. Dear students, let's see another concept. So far we have seen how to add two vectors. Now I want to subtract one vector from the other. So subtraction of vectors. Or vector subtraction, say. Let's try to see. I have a vector, this is A, and say I have a vector B like this. And the angle between them is theta. What I want to do is, I want to subtract B from A. And I'm going to get the resultant vector. So this is what I want to do. I want to subtract vector A from vector, subtract vector A, B from A. I want to subtract vector B from A. Now the diagram that I have drawn on the board follows the rules for addition of two vectors, because the tail of B is coinciding on the head of A. But we have already studied the definition of negative vectors. What it says, a negative vector is a vector that has got equal magnitude but direction is exactly opposite. It will also be an anti-parallel vector. So now what I am going to do here is, when I want to subtract, I see this can be done like this. R is equal to vector A plus minus of B. This way I can do. That means I am going to add the negative vector of B. This is what my intention is. Okay, I shall write here because I want to draw the figure. So vector R is equal to sum of vector A and negative of vector B. This is what I want to do. So negative of B, when I say, that means it's very simple. I'm going to produce this in the backward such that this will have same magnitude as this vector. So in that case, this has the same length as this one, whereas the direction of this vector is exactly opposite. So for me, this is minus B vector. So when vector A and B makes an angle theta, now B and B minus B, this is making an angle of 180 degree. This is 180 degree. This is 180 degree. However, I want the angle between vector A and minus B. Be mindful, to find the angle between the two vectors, I need the tail of minus B vector and the tail of vector A to coincide. So to make the tails coincide, I am going to shift this vector parallelly here. So when I shift here, the tails of minus B and A will coincide here. So what I mean is, I want what is this angle. This will be the angle between minus B and A. So when the total angle is 180 degree and this angle is theta, so do you think that this angle is 180 degree minus theta? So we have found the angle between A and minus B. Now it's very simple. You have to add the two vectors. To do so, I want to first find what is the magnitude. To find the magnitude, already I have the formula. This is going to be square of its magnitude, so A square plus, I am talking about magnitude, negative only gives me the direction. So therefore, square of magnitude is going to be B square plus 2 times magnitude of the first vector A, magnitude of the second vector B, cosine of angle between the two vectors. Which one? A and minus B. So A vector is this one, minus b vector is this one. The angle between them is 180 degree minus theta. So as such, I am going to write 180 minus theta. 180 minus theta. Now 180 minus theta lies in the second quadrant, and in the second quadrant cosine of angle will be negative. So as such, cos 180 minus theta is going to be minus cos theta. So therefore I have r is equal to root under a square plus b square plus, instead of writing 2ab, I have minus cos theta. Or I can rewrite this expression as r is equal to a square plus b square minus 2ab cos theta. So thus I have found what is the magnitude of the resultant on subtracting vector b from a. Now the resultant will have both magnitude as well as direction. I have found the expression for finding the magnitude. Next I want to find what is the direction. To find the direction, you might remember in the last class we studied, let me write tan alpha. So when I write tan alpha, by convention we had alpha was the angle made by the resultant vector. The resultant will be this one. This is going to be the resultant one. The order of the direction of a and minus b is this. And as such, the resultant will have the opposite order. So therefore, resultant is going to have this direction. Resultant is going to have this direction. So this is the resultant vector. Now let me suppose that this alpha is the angle made by the resultant vector with vector A. So in that case, this is my alpha. And if this is the case, then tan alpha, you must remember alpha, the other vector which is not making an angle, so we had b. So if you remember, I am going to have b of sine at the top, angle between the two vectors is going to be 180 minus theta upon a plus b times cosine of 180 minus theta. Be mindful, tan alpha is equal to b. Alpha is the angle between r and a, so I am going to have b split into two components, sine component tan, so sine at the top, cos at the bottom. So therefore I have b sine 180 minus theta upon a plus b cos 180 minus theta, because angle between a and b is 180 minus theta. Now again I said 180 minus theta angle lies in the second quadrant, and in the second quadrant sine is positive, cos is negative. So therefore we are going to have tan alpha is equal to b sine theta. As such, sine 180 minus theta is going to be sine theta over a. Cos 180 minus theta is going to be minus cos theta. So therefore I am going to have minus b cos theta. So thus when you try to subtract vector b from a to find the direction, you are going to have tan alpha is equal to this be the expression. We had in the last class angle beta that the resultant was making with angle b. So if this is beta, in terms of beta also we can express the direction of r as we saw in the last class, and that can be written as, hopefully it will be clear to you, tan beta will be equal to, at the top it will be sine and the bottom I am going to have cos, but instead of b I am going to have this time a. So this will be a sine of angle between two vectors is 180 minus theta upon b plus a cosine of 180 minus theta. Finally I can write tan beta is equal to, sine will be positive, so a sine theta upon b minus a cos theta. So this will be the expression. Now either you write this one or this one, we can represent the direction of the resultant vector. Let's see another property. Let us suppose that we have two vectors a and b and they are non-collinear. Okay, so let me say this is one vector a Non-collinear, definitely the angle between them is not 0. So in that case, let me say B. So when I say they are non-collinear, definitely they are coplanar. That means the two vectors will lie on the same plane. Now, a third vector which is lying on the same plane, say any vector say like this, rather say like this, and let me name this one as R conventionally. Now, what it says is that this R can be expressed in terms of A and B. How? See, please, if I shift this vector over here parallelly, so this will be my vector. This will be my vector. Rather, to make it more understandable manner, let me take the magnitude to be smaller like this. So this is vector R for me. This is vector R for me. Now what I say is that, see, this R can be represented in terms of A and B. How? See, I'm going to draw a line parallel to this one. Parallel to this line, I want to draw like this parallel. And to this vector B, I'm going to draw a parallel line like this. So when I look at this figure, I see that the R vector is nothing but, see, the tails of A and B are coinciding. So this length of vector, this can be one vector and this can be one vector, right? So in that case, I say this length of vector, or this vector having this magnitude, will definitely be some scalar times the magnitude of B, and similarly this is going to be some scalar times of A. Now if I use the parallelogram law of vector addition, I'll see that vector R can be written as the sum of n times A plus m times of B. So from this, what do we understand is that if we have two non-collinear vectors, a third vector lying on the same plane can be expressed in terms of these two non-collinear vectors like this: scalar times of one vector plus again scalar times of another vector. These values n and m be the scalar, whatever be the suitable values we can have to have the sum of these two vectors always equal to this resultant vector. This is another important property. So dear students, today we have seen some of the important problems which is common, and we saw the concept of subtraction of one vector from the other. In the next class we shall see how to graphically add two vectors. We can see pictorially the addition of two vectors. Following that, we will see the product of vectors also. Till then, bye. Thank you very much.